Download this code from codegive.com, link in the description below. Scaling WebSockets to handle millions of connections is a significant challenge, but with the right architecture and tools, it is possible. Here's an informative tutorial covering key concepts, strategies, and a code example to help you understand how to build a scalable WebSocket server. Overview of WebSockets. WebSockets are a protocol for full duplex communication channels over a single TCP connection. They are commonly used in applications requiring real-time data exchange, such as chat applications, live notifications, and online gaming. Challenges in scaling WebSockets. 1. Connection management. Handling millions of concurrent connections requires efficient connection management. 2. State management. Managing user state and data consistency across distributed systems. 3. Load balancing. Distributing connections evenly across multiple servers. 4. Fault tolerance. Ensuring high availability and resilience against failures. Strategies for scaling WebSockets. 1. Use a load balancer. A reverse proxy/load balancer can distribute WebSocket connections across multiple server instances. Tools like nginx or haproxy can help with this. 2. Horizontal scaling. Deploy multiple instances of your WebSocket server on different machines. This allows you to handle more connections by distributing the load. 3. Use a message broker. Implement a message broker, like Redis, RabbitMQ, or Kafka, to facilitate communication between server instances and to manage state or messages across connections. 4. Session management. Store user sessions in a shared data store, like Redis, to maintain state across multiple server instances. 5. Optimize resource usage. Use event-driven architectures, like Node.js or Go, that are more efficient in handling concurrent connections. 6. Health checks and monitoring. Implement health checks and monitoring to ensure the server is performing optimally. Code example using Node.js and socket.io. Here's a simple example of how to set up a scalable WebSocket server using Node.js with the socket.io library, Redis for session management, and nginx as a load balancer. 1. Setting up the WebSocket server. JavaScript //server.js. Const express equals require, express. Const http equals require, http. Const socket.io equals require, socket.io. Const redis equals require, redis. Const create client equals require, redis. Const app equals express. Const server equals http.create server, app. Const io equals socket.io, server. Const redis client equals create client. Redis client.on, error, equals console.log, redis client error, io.on, connection, socket, equals. Console.log, new client connected, socket.id. / handle incoming messages. Socket.on, message, equals. Console.log, message received, message. / broadcast the message to all connected clients. io.emit, message. Socket.on, disconnect, equals. Console.log, client disconnected, socket.id. / health check endpoint. apt-get, /health, req, res, equals. res.status, 200, .send, OK. / start the server. Const port equals process.env.port 3000. Server.listen, port, equals. Console.log, server listening on port $port. 2. Configuring nginx as a load balancer. You can use nginx to load balance WebSocket connections. Here's a sample configuration. nginx http upstream WebSocket server WebSocket _ server _ 1:3000 server WebSocket _ server _ 2:3000 server WebSocket _ server _ 3:3000 server listen 80 location / proxy _ pass http / websocket proxy _ version 1.1 proxy set header upgrade $http upgrade proxy set header connection upgrade proxy set header host $host proxy set header x real IP $remote address proxy set header x forwarded for $proxy add x forwarded for proxy set header x forwarded proto $scheme. 3. Running multiple instances. You can use Docker to run multiple instances of your WebSocket server. Here's an example Docker file. Docker file. Docker file. From node 14. workdir/app. Copy package.json package lock.json/ run npm install. Copy. cmd node, server.js. To build and run multiple instances with Docker. Bash. Docker build t-WebSocket server. Docker run dname WebSocket _ server _ 1p3000 and 1:3000 WebSocket server. Docker run dname WebSocket _ server _ 2p3000 and 2:3000 WebSocket server. Docker run dname WebSocket _ server _ 3p3000 and 3:3000 WebSocket server. Conclusion. Scaling WebSockets to millions of connections involves careful architecture design and the use of best practices. With a solid approach using tools like nginx for load balancing, Redis for state management, and a scalable server architecture, you can build a WebSocket server that handles significant loads effectively. Further steps. Implement message persistence with your chosen message broker. Enhance security with HTTPS and authentication mechanisms. Optimize your application for performance with techniques like clustering and caching. By following these guidelines, you can create a robust and scalable WebSocket server capable of handling millions of connections.